So this is my midterm clawback. So I'll be working on problem 3. Okay, first thing is, okay, let's restate the problem. Okay, so here we can see two planes, plane A and plane B, and we have and it is defined by, and there are two normal vectors which are defined, which is u3 u3 and u4, and these both are yeah, they're pretty much they are perpendicular to the planes. Okay, then and they also have a vector v here, which is at the intersection of intersection of both the planes. Okay, and now the question is uh, to find out a scalar constraint equation, okay, that ensures that this vector v is perpendicular to ax, the unit vector ax. Okay, then talking about the core fundamental of the problem, this can be used by using simple fundamentals of vector operations, which is cross product and dot product, which is cross product and dot product. Okay, and okay, talking about the misunderstanding I have and how I'm defining things in a different way right now. uh, so initially during the exam day when I saw the problem, I didn't think about vector fundamentals. I directly dived into thinking about constraint equations and how, and I was like trying to figure, okay, how vector v that a constraint equation uh, could make vector v perpendicular to ax. I totally forgot about the fundamentals of cross product and dot products, which I refreshed right now, and I'm able to understand the problem better and solve it. Okay, so let's solve the problem. Okay, so now we can see that okay, now we can see that this vector v is kind of parallel to so it's kind of parallel to a. Okay, and it's parallel to the b plane as well, a and b. Okay, so we know that the vector v is parallel to planes a and b. Okay, since they're parallel to both the planes a and b, okay, they should be perpendicular to the normal vectors. Okay, since they're plane, so therefore they're perpendicular to the normal vectors, which is u3 and u4, u3 and u4. Okay, and here, okay, u3 and u4. Okay, now we know that v is perpendicular to u3 and u4, and now we can use the cross product rule here, which says that a cross product of two vectors, so in this case it will be u3 and u4, should give the direction, or should give a vector which is, it should give a resultant vector which is perpendicular to u3 and u4. Okay, and we already know that v is perpendicular to u3 and u4, so the cross product of u3 and u4 should give us v. Okay, it should give us the direction, and it should also give, yeah, pretty much give the direction of v. Okay, this is the equation 1 we have. And next concept, and the next thing, and the final thing, and the most important thing in the question they've asked is to write a constraint equation which makes sure that the vector v is perpendicular to ax, and using the dot product fundamentals, which says that if two vectors are perpendicular to each other, the dot product is 0. So basically what it means is vector v dot the unit vector ax is equal to 0 if they are perpendicular to each other. Okay, this is equation 2. And by substituting equation 1, that is the value of v, in equation 2, we can write a constraint equation which is u3 cross u4 dot ax is equal to 0. So this will be the constraint equation which will make sure that vector v is perpendicular to ax. And that's my answer. Thank you.